In the previous OEG415 video, I sketched out all the external features of the Doodlebug. In this video, I will design the internal structures that turn that collection of parts into a buildable model. This covers another 6-ish hours of CAD, though I have cut a little bit, mostly sections of rotating the model or staring at the drawing in the interest of time. I did the same for part 1. Basically, I want to rebuild the entire model with a practical, somewhat optimized internal structure. For this pass, I start from the front and work my way back. The first challenge involves making the 1LU offset for the front face work with the greebles on said face and the 1LU offset for the side doors. All the while, I have to consider how to bridge the gap over the power bogey. I reduce the transmission frame from a rectangle to a U, making sure that the two prongs have enough rigidity. I originally did this to minimize the number of 1x2x1 curve slopes, but I will eventually need this space for more structural connections. Then I spend a ton of time figuring out how to attach the inverted sections with the panels around the front wheels. I try all sorts of hinge combinations and snot bricks, but I can't find anything with enough structural integrity that will also clear the transmission. I almost decide to put it off until I have more visibility into the roof construction, but then I finally make a breakthrough. I stumble across a relatively compact inversion using a clip and a nipple. This too wide, 2-plate high connection also supports the walls from beneath. I start coloring external parts to better see what final assemblies will look like. I usually leave unspecialized internal parts blue or red. After test fitting the bogey and checking the clearances for turns, I add the sliding doors behind the drivetrain and move on to the passenger compartment. With the position of the flywheel and motor already set, I can locate the mounts for the side panels where they don't interfere. I add a bulkhead to the area between the front and rear compartments, as forces will concentrate there due to the lack of connections going forward. Once I have the total length of the side paneling, I then do some work on the rear face and the rear doors. While the front and back faces are nearly identical, I need to build and mount them differently to accommodate the different surrounding greebles, mostly the 2 pairs of side doors. Now I can arrange the 2 sheets of plates beneath the roof. This layer and the base provide most of the model's structural integrity, since most of the features in the sides don't contribute any meaningful stud connections. I use 1 wide plates to dodge the flywheel and 2 wide plates everywhere else. I make sure that the layers have enough stud overlap between themselves and between the perpendicular plates over the internal bulkheads. Finding a clean combination of parts does prove a bit tedious, but I eventually move on to the roof itself. I know I have to use those new curve slopes to dodge the transmission, flywheel, and electronics, but I use the older 2x3 curve slopes everywhere else for structural integrity. I also have to work out how to put roofs over the aforementioned elements. In particular, the section over the flywheel will have to connect at the ends. Now comes an annoying part. I want to route some structure around the battery box and receiver to connect the floor and the ceiling, but I realize I need to leave space to run wiring. I decide to use panels for the supports and limit their number. I color them black since they will show through the windows. Unfortunately, I can't test actual wiring in LDD, so I can't yet see if I left enough space. I make sure that the panels join nicely to the roof, and then I can finally complete that as well. The thin section over the battery box can attach to the PF connector, while the thin section over the transmission can attach to the plates on the sides. The flat shelves at the front and back of the roof let me cover the 1 LU gap between the end faces and the body using 2x2 plates with 2 studs. I add some of the greebles and basically finish the body. Next, I clean up the front bogey, sorting out how to attach the frames and the tiny cow catcher. I reduced the number of frame connections in favor of more structural elements. The 2x3 plate prevents the frame from rotating around the single stud connection. I wanted to make it easy to swap out the geared bogey and swap in a train motor, but the vertical drive shaft goes directly into a gear inside the gearbox. The rear bogey has a bit more weirdness. The extra stud between the axles makes the steps wrap around one of the flanges. This overhang seems okay on paper, but it will need some physical testing to see the actual fitting and fragility. Otherwise, I implement the frames and the cow catcher mostly the same way as the front bogey, though this side obviously does not need the extra height. I do a bit more clearance checking on both the geared front bogey and the train motor, but this will ultimately need physical testing as well. From there, I transition to the greebles underneath the body. I almost always end up doing these last, as they typically don't cause much trouble. I like referencing models because they usually have good top and bottom views, whereas actual prototypes, especially older or more obscure ones, often do not. I add some final touches to the roof, the vents and the radiators in the front, and all these bumps along the cabin. And I clean up the various mounts for the removable sections above the transmission, flywheel, and electronics. Finally, I take some time to sort features into groups. This does not necessarily affect the design, but the organization makes it easier to break up the model for reference and for making instructions. I also convert internal parts into available colors. Again, this does not affect the actual design, but accurate colors make for a nicer CAD model with which to take screenshots or make renders. See the thumbnails for parts 1 and 2 of this series. And that's it for part 2. I now have a buildable model from which to make a physical prototype on which I can make further adjustments before ordering parts for a final build. Stay tuned for part 3, which will cover all of that and more, and consider subscribing if you like what we do. On that note, this is the end of the video, so have a nice day.